discuss the things about permutations and combinations. Okay, so I'll go first with the permutations. Okay, so permutations, it pertains to arrangement of objects in which order is important. So in permutation, the order is very important. Okay, then okay, in the study of permutation, okay, the inclusion of the word n factorial, okay, can be heard, okay, or can be seen. Okay, so in terms of the n factorial, okay, say for example you have 5 factorial, so it means that 5 must be multiplied to the next lesser value or lesser number. So that is 4, then by the next lower number. So after the before the 4, so that is 3, then times 2 times 1. So if you have 5 factorial, so it means that you will evaluate. So it will be 5 times 4 times 3 times 2 times 1. Okay, so then also in permutations, we have the so-called 3. We can call this one as types or subparts of permutation, and that is, the first is the permutations of an object. Okay, and in the study of permutation of an object, we can see the two involved formula, and that is the NPN, the taken all at the time, and the NPR, taken R at the time. Then the formula for the NPR, okay, taken R at the time, permutation taken R at the time, the formula is n factorial all over the quantity of n minus R factorial. Okay, so after that one, the study about the circular permutation. Okay, from the word itself, circular permutation, it means that this permutation, okay, can be used when you are dealing with, say for example, you are finding the ways, okay, of arrangement, a circular arrangement around objects. So that is the keyword. So you can use the circular permutation. The circular permutation has this formula, which is P is equal to n minus 1, the quantity of n minus 1, okay, factorial. And the last, we have the so-called distinguishable permutation. Okay, say for example, uh, we have a so-called n sub 1, n sub 2, or um, distinguishable, what do you call this one, distinguishable, say for example, color. We have pink, red, violet. So those are distinguishable, but you must focus in the object. If it is a marble, then focus on the color. Okay, so distinguish first. Okay, say for example, we have 5 color red marbles, 6 color brown marbles. So that can be the n sub 1 and n sub 2. Because the formula for the distinguishable permutation is n factorial. Okay, n factorial all over uh, n sub 1 factorial times n sub 2 factorial times n sub 3 factorial. Then going to the limit n sub k factorial. So as long as, okay, uh, a distinguishable object, okay, is been displayed, okay, and can be certain, so you can use the distinguishable permutation. And your teacher urged you to get the ways in how you can that, say for example, that marble can be arranged in a row, so you can use the distinguishable permutation. Okay, and take note that in permutations, arrangement and orders are very important. Okay, to have a comparison, when you go with the study of combinations, an arrangement of an object, or an object with no repetitions and order is not important. So here, the order is not important. Okay, the order is not important. Okay, so most of the time, the word choose or select, okay, is monotonous, or most of the time a use word, okay, when you are studying combinations. Okay, so yeah, if you're good in English, some synonymous word with combine, okay, those are like fusion, mixing, mix. So those are synonymous word with the word combinations. And the combination is represented by the capital letter C. Okay, so that is N, capital letter, small letter N, capital letter C, and small letter R. So NCR is equal to, okay, NCR is equal to N factorial all over the quantity of N minus R factorial times R factorial. So that is the formula for combination. Again, the formula for combinations, listen carefully. N factorial all over the quantity of N minus R factorial times R factorial. Okay, then yeah, so those are the things that is included in the study of combinations. Okay, so take note of that because those things are very important. Okay, so take a look at some of the examples. Okay, so this is the video, not mine, this is not my slide. Okay, but I want you to study more about this one. So for example, see your locker combo is 5432. So here, since arrangement is very important, order is very important, so you can use the permutation. Okay, you can apply the factorial. Okay, so you can apply the factorial. Okay, and yeah, knowing the probable arrangement. Okay, or probable yeah, outcomes. So that is that. Okay, so yeah, those are examples. Then, so a lot of ways, a lot of arrangement. Okay, so okay, so for example, how many ways can 5 cars line up for a race? Okay, so how many ways can 5 cars line up for a race? So here, since uh, it pertains to uh, the ways, how many ways can 5 cars line up for a race? So you can apply, okay, since that is race, okay, most of the time, okay, if race, that is about what do you call this one, a permutation. Okay, you know, apply the permutation here. So, and also number 2, in how many ways can 5 players for a team be chosen from 7 players? So here in this case, you will apply the combination. For number 1, permutation. For number 2, combination. So take a look. Okay, so these are some questions related to it. Okay, then yeah. So yeah. Okay. So these are some of the problems. Okay, so in how many ways? So that's why earlier I said that in how many ways can 5 cars line up for a race? So that is permutation, line up. So therefore arrangement is very important. And next for number 2, in how many ways can 5 players for a team be chosen? The word chosen. So when you are choosing, it's not right that you must arrange first. No, that is not important. So next, number 3, in how many ways can 3 guitar players be seated in the first second? So there are the so-called arrangement, okay, or order. So therefore that is permutation. For number 4, in how many ways can 3 paintings be chosen to display from a collection of 10 artworks? So be chosen. Okay, in this case, that is the word be chosen. In how many ways can 3 paintings be chosen to display from a collection of 10 artworks? That is combination. The word chosen. Because not all the time that you are choosing, okay, you need to arrange. So most of the time, order is not important. So, and for number 5, yeah, to choose again, so that is combination. So the keyword for combination is choosing, okay, sometimes select. Okay, so take note of that. Take note of that. Okay. So and yeah, in calculator also. In calculator also we have, okay, you can see this one, NPR or NCR. So you can type on in the in, say for example, you have scientific calculator. Just type the okay, first in calculator, okay, locate first where's the NPR and even the NCR in the calculator, in the keypad. Okay, then after that one, you apply. So for example, 5, your N is 5. So you click 5, then P, then, okay, that P can be, okay, or you can get the P by using the shift button. Then followed by R. If, say for example, that is 4. And take note, guys, that, say for example, your R becomes 0. Okay, remember guys, in permutation we have NPR that taken R at a time. Say for example, your R becomes 0. The answer would be 1. The answer would be 1. But what if, say for example, your R becomes 1? Your R becomes 1. So, say for example, 5P1. Okay, your answer will be DN. Okay, so for example, you have 5P1. Okay, so the answer is 5. Okay, again, so for example, your R becomes 1, NP1, therefore your answer will be the N. If your N is 4, then that's your answer. If your N is 3, that's your answer. Okay, so that's it. Then, if you encounter 0 factorial, okay, in mathematics, okay, 0 factorial has the value of 1. 0 factorial has the value of 1, and 1 factorial also has the value of 1. Okay, so that's it. Then, yeah, remember those things, guys. Then, okay, be good in multiplying, because most of the time when you are dealing with combination and permutations, okay, not only the addition and subtraction is or are applicable, but most of the time the multiplication type of operation is, okay, very significant. Okay, so you must know how to multiply large numbers, because sometimes, okay, upon calculating, like, okay, in the problem of permutation or combination, most of the time, okay, we can get the answer, which is, okay, millions. Okay, we go with that, millions. Okay, we can get that value, okay, so higher than 1,000. Okay, so that's why you need to be good, okay, in terms of multiplication. Most of the time, or most especially if you don't have this so-called scientific calculator. Okay, then guys, you can do this in your, you can apply, you can, okay, do this in your house. apply this one. Okay, so do it. Okay, challenge yourself. Remember that, okay, if you want to be good in math, okay, first change your mentality about math. Okay, those misconceptions must be deleted, omitted. Okay, that's all for this day, guys.